In this lesson, we will learn how an aeroplane achieves flight through a combination of power from the engines and lift provided by the wings. A big aeroplane such as this depends on the laws of physics to fly. What are the forces acting on an aeroplane? How do the engineers create a machine that uses the laws of physics to fly high and fast? What are the forces acting on an aeroplane? The force acting downwards is the weight of the aeroplane. The wings provide lift. When the weight of the aeroplane and lift are balanced, the aeroplane maintains a constant altitude. The engines give the aeroplane forward thrust. Since the aeroplane is flying through the atmosphere, it receives a lot of air friction in the form of drag opposing the flight direction. When the forward thrust is balanced with the drag, it enables the aeroplane to fly with constant velocity. The forward motion of an aeroplane is made possible by the engines of the aeroplane. The huge engines provide the power that creates forward thrust. A jet engine takes in air that is compressed. The compressed air combines with fuel and ignites, producing a high-temperature, high-pressure gas. This gas is forced out the back of the engine as exhaust, creating a forward thrust. The forward motion as a result of engine exhaust being forced out the back can be explained using the principle of conservation of momentum, which states that the total momentum in an isolated system is constant. Thus, when the high-velocity gas momentum, an equal forward momentum is created. The engine of an aeroplane is part of the propulsion system. The propulsion creates a forward thrust that equals the drag to enable forward motion with a constant velocity. If the forward thrust is more than the drag, then the aeroplane accelerates. How does the wing of an aeroplane create lift? An aeroplane wing is an aerofoil. An aerofoil is shaped so that its upper surface is longer than the lower surface. Air passing over the upper surface moves faster compared to the lower surface. This creates an area of low pressure above the wings. The difference of pressure above and below the wing creates an upward force called lift. The lift increases with speed and eventually overcomes the downward force, enabling the aeroplane to take off. The physics involved in an aerofoil is called the Bernoulli's principle, which states that an increase in velocity marks a decrease in pressure. An aeroplane wing has flaps, which can be extended to increase wing area and lift. When an aeroplane rolls down the runway with increasing speed, the flap is extended downwards. This will create a higher lifting force upwards, and the aeroplane will take off. An aeroplane tail wing has rudders attached to it to enable the aeroplane to turn left or right. The rudder works on the same concept as an aerofoil. When the rudder is turned left, the tail wing area is curved and air moves faster on the curved surface. The difference in pressure introduces a force acting on the rudder that pushes the tail wing and thus turns the plane to the left or right.